Welcome to this video where we will talk about enum and typedef. First, let's start with enum. The enum keyword gives us the possibility to create a new data type with a finite set of possible values. For example, we can create an enumeration of weekdays, where we put the 7 weekdays. So a variable of type day can take one of those possible values we put in the enumeration. Let's implement this example. The syntax of enum is, first we have the keyword enum, then we have the name, then between curly brackets we have the different possible values separated by commas. Let's now do our weekdays example. First we have the keyword enum, then the name, let's choose day for example. It's better to capitalize the first letter of enum name. And then we set the possible values between curly brackets separated by commas. So we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Let's do a second example. We assume that a difficulty can be easy, medium, or hard. So we create an enumeration named difficulty. In the possible values we put easy, medium, and hard. And if we want to declare a variable of type difficulty, first we write enum, then the enum name which is difficulty, then the variable name, let's choose game difficulty for example, and now we created the variable so we can initialize it to medium for example. It can take one of the possible values only, easy, medium, or hard, otherwise you would get an error. You have to know that possible values have an index for each one. The first one is 0, the second one is 1, and the third one is 2, and so on, because we start counting from 0. So you can assign the index instead of the value. So in our last example, if we initialize our variable to 0, it's like we initialized it to easy, because easy, which is the first element of our enumeration, has the index 0. We can verify it with a condition like this. Now let's move to typedef. Typedef is a feature in C language that gives us the possibility to create an alias of a data type. For example, we're making a game where the players have different scores of type int. We can directly use the int data type, it's not a problem, but we can also use typedef to create an alias named score, which is of type int. So we will be able to create variables of type score. Let's do it right now. The syntax is that we have the keyword typedef, after it the data type, after it the alias name, and that's it. So to take our last example, we have the keyword typedef, then int, then we can choose an alias name like score. So now we can declare variables of type score, which are in reality of type int. Let's make two variables of type score, so it follows the same syntax. First we have the data type, which is score in this case, followed by the variable name. Let's choose player1 score for example. Then we can initialize if we want. We can put 100 for example, because it's an integer. Second variable we have score, then for example player2 score, and let's initialize it to 300 for example. As I said earlier, you are not obliged to do it. Typedef can also be useful to shorten a data type name. If you read the table of the data type lecture, you would know that we have a data type named inside long int, which is very long and exhausting if we write it each time we want to declare a variable of that type. So what can we do is that we use typedef to create a shorter alias for this data type, ullint for example. So we have the keyword typedef, then the data type which is inside long int in this case, then the alias name which is ullint. So now instead of writing inside long int each time, we can directly write ullint. We can also use typedef with enum. If you remember, to declare a variable of a type we created with enum, we had to write the keyword enum, then the data type name, then the variable name. We can avoid having to write enum at the beginning by using typedef. So for that, we have the keyword typedef, then the keyword enum, then the set of possible values, then the data type name. If we do it with our enum example of difficulty, we write typedef, then enum, then the set of possible values, which are easy, medium, and difficult, then the data type name, which is difficulty. The name comes at the end this time, don't forget. And now we can create a variable of type difficulty without writing enum before it. We just write difficulty, then the variable name, then we can initialize if we want. Now that you know enum and typedef, let's move to the next video to talk about the boolean data type. See you there! Welcome to this video where we will talk about the boolean data type. First, you have to know what is a boolean statement. A boolean statement is a statement that can be either true or false. That's it. For example, if I tell you 10 is bigger than 5, it's true, and it's a boolean statement. If I tell you 3 is equal to 6, it's false, and it's a boolean statement. So we have what we call boolean variables. A boolean variable is a variable that can hold the value true or the value false. It has two possible values, that's it. Boolean variables are really useful in programming. We can use them in conditions, loops, functions, etc. But the boolean data type isn't initially available in the C language, but we have some ways to be able to use it. First one is to use an integer with bool as an alias, where 0 represents false and 1 represents true. So we write typedef int bool, and now we can create variables of type bool. But what we want is to be able to write true and false instead of 1 and 0. So a better way is to include the stdbool.h library. And by doing it, we can now directly declare a variable of type bool and it can take the value true or false. A third way to do it is by using an enumeration, the feature we've seen in the last video. So we write typedef, then enum, then the possible values which are false and true, then name which is bool. We wrote false before true because remember that the first element has the value 0 and the second one has the value 1. This is why we put false before true, so that false takes 0 and true takes 1. And now we can declare bool variables and we can use false and true as values. So now we've ended with the boolean data type, and let's move to how to print a variable. See you in the next video. Welcome to this video where we will learn how to print a variable. If you remember, in the first little program we've made in the introduction chapter, we used print function to print hello world in the console. Now we will use this function to print variables. You have to know that in the printf function we have to put a formatted string. A formatted string can contain normal text like we did with hello world. It can also contain special characters preceded by a backslash. For example, to go to a new line we use \n. And to print variables we have to use a format specifier. A format specifier contains first a percentage symbol followed by a code depending on the data type we want to print. For example, if we want to print a value of type int, we write %d. If we want to print a character, we write %c. If we want to print a string, we write %s. If we want to print a value of type float, we write %f. You can check the link in description to find the format specifiers of other C data types. And after the formatted string, we have to precise the value or the variable related to each format specifier respectively, separated by commas. Let's do an example. Let's declare a variable of type int initialized at 5. So now, if we want to print it, we write in the formatted string the value of our variable is %d, and after it we put a comma, then we write the name of our variable, and we close the parenthesis and we put a semicolon obviously. And if we compile, we get 5, where we put a format specifier. Let's do it now with two variables. We declare a second variable of type char this time. Just as an example, let's initialize it at lowercase a. Now in the formatted string, we can write the integer is %d and the character is %c. We use %c because it's a character. We want to print a character. And after the formatted string, first we put the value of the first format specifier, which is our int, then we put a comma, then we put the value of the second specifier, which is our character. And we get this. If we compile, we can see the result. You are not obliged to use a variable, you can directly set a value. Let's add format specifiers in our formatted string. Let's add a %d and a %s, for example. So now we have to add two values after our variables. We can put the value 8 for the int type, for example, and the value programming for the string. It has to be between double quotes, and we get this result. You can try more example in your IDE to practice, because learning programming is all about practicing, not just hearing the instructor. See you in the next video to see how to scan a variable this time. In other words, how to get input from the user. Welcome to this video where we will learn how to scan a variable. In precedent videos, we always choose the value of the variable by ourselves. But what if we want to give to the user the possibility to choose the values of variables? In other words, we want to choose the values of variables during the execution of the program and not before. For that, we have some functions to be able to do that. The one that we will often use is scanf. So let's start. The scanf function uses the same principle as printf. We need to use a formatted string, so we will use format specifiers. Let's start with a simple example. For example, we can ask for the age of the user. For that, we create a variable of type int. We can name it age. Now let's print that we want the user's age, so we can print how old are you, for example. After it, we use the scanf function to receive the result and put it in the variable we created. So we directly put the format specifier, %d in this case because we will scan a variable of type int, and after the format specifier, we need to precise which variable we want to modify by the user input. But wait, in printf we just needed the value, but here we want to modify the value of the variable, so we need the address, the memory location. So we have to add an ampersand just before the variable name to give the address and not the value. It's what we call a pass by reference. It's not a problem if you're confused about it because we'll talk about it again with more details in the chapter about functions. But now, just keep in mind that when we want to scan a simple variable like an integer or a character, we have to add an ampersand before the variable. Let's go back to our example. Let's print the variable age after the input to see the result. If we compile and we write 19 for example, you can see that the value of the variable became 19. By the same way, we can scan a character or a float for example. We can also scan a string. I don't know if I should talk about strings because you may be confused, but don't worry if you don't understand something because we'll have a whole chapter about strings. So let's declare a string. One of the ways to declare a string is to use the char data type. Then the string name, then just after it, the number of characters of the string between brackets. Now we can scan the string, but we don't use the ampersand because it's already an address, so we don't need it. We don't need to add an ampersand. You're not obliged to understand this now, just keep in mind that to scan a variable we use the ampersand except if it's a string, then we don't. Let's make a simple program to get the informations of the user. We want to know his name, the first letter of his first name, and his age. So we need these variables. Here we put 30 because we assume that 30 characters will be enough to store the user's name. Now let's print and scan variable by variable. First let's ask him for his name. Now we scan the name. It's a string so we don't use the ampersand. Then we ask for the first letter of his first name. It's a character so we use the ampersand. Then we ask for the age. It's an integer so we use the ampersand. And at the end we print the information. And after each scanf, we put getChar instruction. I recommend you to do it because you have to know that when you end your input, you press on enter on your keyboard. It creates a new line, and you have to know that new line is considered as a character. We've talked about it in printf, it's backline f if you remember. So we use getChar to receive that character and avoid giving it to the next scanf. Now let's try our program. I'm gonna give my name, then the first letter of my first name, then my age, and now we get the information printed. Last thing about scanf I want to talk about is that by scanning a string with scanf, it's gonna take only the part before the first space character, so we can't scan a string with multiple words. As you can see here, I wrote hello world in the input, but the string took only hello. And also scanf isn't really safe. For example, here I put 30 characters as the size of the string. But imagine if the user writes a string that has more than 30 characters. It can be really dangerous for our program. It can provoke a buffer overflow, and a lot of cybersecurity attacks use buffer overflows. This is why we're gonna see other secure ways to scan a string properly and avoid this problem in the chapter about strings. And also, you have to avoid two things. writing plain text in scanf, and scanning multiple variables in one scanf function. Avoid these two things because they can provoke bugs. See you in the next video to talk about size of and limits point h.